Hello and welcome to this new lecture, new section in this course, AI for Risk Management and Compliance Excellence on fraud detection and prevention. So in this section, we will give you a good idea of how to use, AI for excellence in fraud detection and prevention. And in this particular lecture, you will learn about behavioral modeling using past fraud cases, right? So how do you think you can you can use behavioral modeling using the past fraud cases to enhance fraud prevention? Any thoughts on that? Using behavioral model powered by past fraud cases is one of the most effective ways to detect and prevent frauds in real time. How does it work? It works by learning patterns of normal and abnormal behavior and uncovering non obvious correlations or outliers that traditional rules might miss. Now, let's take a look at what are the detailed steps that you can take to build and use behavioral fraud models. Let's look at that. So, you need to begin by defining the objective and scope of the fraud prevention, and you need to clarify a few things before modeling. Now, the kind of questions you need to answer are like what type of fraud? Is it a credit card fraud, insider trading, synthetic identities? What is the business unit? Is it for the payments? Is for insurance, telecoms, trading? And what is the output? Output, right? Is it a fraud probability score, fraud not fraud label, or alert flag? So these are the things, minimum things you need to clarify before modeling and define the objective and scope of fraud protection. Then you gather and structure historical data, including the fraud labels. And for that, you pull historical data sets with fraud labels where available, including transaction data and the things that you could do. Pull in is like amount, time, location, merchant, currency of the transaction. You could look at user behavior in terms of number of times logged in, device use, session paths, you could look at contextual data. You need to look at contextual data like weather, holidays, currency rate, and fraud labels, confirm fraud cases from past audits. And make sure that your data is timestamped to support sequence modeling, right? So that's how what you need to do in gathering and structuring the historical data. Then you engineer behavioral features, right? And what you do there, you transform raw data into behavioral insights for each user and each entity. And the examples of behavioral features are like, if your behavioral insight is spending pattern, your feature might include average transaction per hour, per day, per week. If you're looking insights on time-based behavior, then your transaction outside typical hours, which are normal, if you're looking for geo or device pattern, then you will probably need to track features would be like new IP, new device, new country. If you want insights into sequence or path analysis, then you need to track sequence of action before fraud. And if you're looking at velocity, the features might be number of transactions in past 10 minutes or an hour. Now, please remember, you can also use sliding windows, session aggregation, and temporal statistics. So that's what you can do in engineering behavioral features. Then you train behavioral models to spot anomalies and correlations. And there you can use machine learning to find patterns that are hard coded rules cannot. Now, what are the common approaches? You can use a supervised learning if label fraud data exists. And the kind of things that you can see are like random forest, which is easy to interpret, handles noise as well. XGBoost Light GBM that is highly accurate, handles imbalanced data, and neural nets using MLP and RNNs for sequential patterns and embeddings. Or you could use unsupervised or semi-supervised learning for rare fraud cases. And there your models could be autoencoders that reconstruct normal behavior and flag unusual activities. Isolation forests which can detect rare and extreme behavior, and clustering and outliers to spot behaviors that don't belong. So that's how you can train behavioral models to spot anomalies and correlations. Then you are ready to discover hidden correlations and non-obvious patterns. Now, these ML models can uncover subtle fraud indicators, like login from unusual device plus high-value transaction in last 5 minutes or in less than 5 minutes. Then a customer placing identical order under different accounts. A spending pattern that mimics a known fraudulent profile. In that, please remember to, when you want to discover these, please use feature importance using the scores of SHAP value to understand which feature influences the fraud prediction most. Because once you figure out the feature, you know what to track, right? So key thing is to figure out what are the right features. So then you can deploy, once you have figured that out, you can deploy for real-time scoring. You need to integrate your behavioral model into your production system. And there your input would be like user behaviors, session data in real time. Your output will be fraud risk scores or fraud alert label. And for integration, you can use API or stream processors like Kafka, Flink, or Spark. And you can set thresholds like if the score is greater than zero point 0.8, block transaction. If it is zero point 0.5 to zero point 0.8, flag for review. So that's how the deployment for real-time scoring can happen. Then you can also visualize, monitor, and improve. You need to actually visualize, monitor, and improve, and you need to build dashboards to monitor fraud score distributions, investigate flag behaviors, compare fraud versus normal patterns. And then you need to use feedback loops to feed confirmed outcomes back into the model and improve precision and reduce false positive over a period of time. So that's how the visualization, monitoring, and improvement can happen. Now, what are the tools and libraries you can use? Let's take a look at them. So for feature engineering, you can use Pandas feature tools and TS Fresh. For modeling, Scikit-learn, XGBoost, LightGBM, TensorFlow. For explainability, you can use SHAP and Line. And for real-time scoring, you can use ONNX, TorchServe, and TensorFlow serving. And for deployment, you can use Flask, Fast API, MLflow, and Airflow. So these are some of the tools and libraries that you can use. So now let's take a look at a real-world example of a telecom fraud detection. In this case, the historical data of 1 billion plus call records and 20,000 K label frauds were investigated and used. Behavioral modeling was done using three such features like average call duration per country, night calls versus day calls ratio, and device switch frequency. And the models they used was gradient boosting plus autoencoders. And the impact was 93% precision, real-time blocking of 80% plus fraud attempts. So that was a good successful example of telecom fraud detection. Right. So let's take a look at the business benefits of using behavioral models to enhance fraud prevention and detection. So, first is obviously you can spot subtle multi-step fraud, which are difficult to detect otherwise. And here that can help you detect sophisticated attackers, big stake kind of people. Then it can lower false positives, which basically means that your predictions become more accurate and you have fewer customer complaints. Then real-time fraud blocking can happen that can save billions in potential losses. And you learn continuously. System gets smarter with every new case. So these are some business benefits. So what do we do next? So in the next lecture, we will look at another way of fraud detection prevention, and that is of using graph analytics to uncover fraud networks. Not only fraud, but network of fraudulent activities, people, events, places. So that's what we will do in the next lecture. So thank you so much for watching this first lecture on fraud detection and prevention. I hope you're continuing to learn new things, continuing to enjoy, and I do look forward to see you again in the next lecture. Please feel free to message me if you have any questions. I'll be happy to answer your questions, and do download the PDF file to take a look at anything that you need.